first off, thanks for having me today. Thanks for joining this Codecamp session. My name is Vincent Bortone. I am a technical manager at Cognizant Softvision, where I manage teams and architect enterprise solutions. And I've been with Cognizant for 3 years. Before that, I spent a long time in the sort of legal technology space, about 18 years in that role before sort of moving over to Cognizant, where today, still in the professional services space mostly, but it's sort of a different type of business. And today I'm going to talk about distributed systems and a particular framework for distributed systems known as Dapper. I'm going to encourage anyone, if anyone has any questions, please share them in the chat, and we'll definitely try and get to everything at the end. Today's makeup of the presentation will be primarily, there'll be a slide deck followed by a demo session where we'll go into using Dapper, most specifically with .NET, and sort of how to utilize it in a local environment to sort of ease the development of microservices. And and so let's just get started. So first off, I just want to make a quick clarification. So when I discussed this presentation with a lot of my colleagues, a lot of people initially asked me, well, isn't Dapper a ORM? And I said, well, that's a different Dapper. So so for people who came here maybe expecting a conversation on Dapper, which is the ORM developed by the Stack Overflow team, right? Which is a very popular lightweight ORM. This is actually not about that. So I just want to just clear that up before we get going. So now that we sort of move into Dapper, before we talk about Dapper, why don't we talk a little bit about just microservices in general and sort of some of the benefits and challenges that go into developing, implementing, supporting them, right? So, so definitely let's start with the benefits, right? One of the main benefits is you have this independently deployable and scalable unit of code, of processing, right? They can be deployed independently. Best practices usually recommend that they are in their own repo. They will they have their own CI/CD pipeline, and they're usually managed by their own team, right? So Amazon had this classic description of a good sized team, right, where we call the 2 pizza team, where you need enough people. The team should be large enough just that 2 pizzas can satisfy that team. Now depending on people's appetite, it may depend on the size of your team, but it's definitely a good rule of thumb. And other benefits include like fault isolation, right? So in sort of a more traditional development platform, the term today everyone uses is monolith, right? But essentially, where your traditional application can still be tiered, it can still be modularized, but at the end of the day, often they are running under the same process, or at least on the same server, where in those scenarios, a fault may impact more than just the small subsection of the application. And this is definitely one of the benefits that microservices have. And a lot of that has to do with the sort of the infrastructure and the fact that they usually run in their own process. And, again, best practices dictate that they usually have their own database, and therefore really are individual sort of units that can be, can essentially go down or, and support without bringing the whole application down. And finally, the smaller code bases, right? So this kind of goes back to number 1, but essentially, those of you familiar, especially, and as hopefully developer focused, right? So a lot of us today live and die by the sort of solid principles, and sort of that idea of single responsibility, very isolated, functionality, do one thing, do it really well, and sort of microservices promotes that. And you'll find that theme throughout this presentation, right? So when we get into Dapper and what it provides is another great example of sort of that single responsibility and having something that does something very well, but just does that. And so with all these, great benefits, of course, we have, there's always challenges, right? There's always there's always compromises in our development. There's a great question leading up to this presentation. You asked about the GraphQL, right? What could be a downside? Like, in our world, right? We all know that there is no perfect solution for things, right? And so my favorite question or answer to a question often is the it depends, right? So I find myself in the consulting world often using that as a sort of when people sometimes look for definitives. The truth is there's lots of great solutions. And today, Dapper, we'll talk about Dapper as one great solution. And at the end, hopefully we'll talk about, some of the alternatives and so sort of what else could be used instead. But back to the complexities of microservices, right? So first off, we have this idea of complex communication, right? So it's great that you have all these isolated services that are their isolated processes. They run on their own, but how do we now talk to those isolated processes in an easy manner? A lot of patterns have evolved around, sort of remote communication. So, today I would say between, service buses, event buses, sort of that publish subscribe model at a higher level, where eventing sort of come into their own and played a major part in supporting this type of infrastructure. Debugging, integration testing, right? So one of the biggest challenges of debugging microservices is the fact that they are, again, across processes. How do we, if we're sitting on a local machine, how do I test, when microservice A goes, makes a call to microservice B or publishes an event that the microservice C needs to respond to. So these are challenges that come along with this development model. And finally, we have this idea of what I'm calling interface control. But essentially, with the microservices being sort of independent, but not truly independent, right? They are being communicated. They don't live in a complete bubble by themselves, right? So they have to provide an outside interface for different components to talk to them, whether, again, it be responding to a service bus, or maybe it's a REST API or a GraphQL API. In either way, you need, if you need to make changes to that interface, you have to understand that there are implications to that, right? So today, there's emphasis on, standards around versioning of your APIs, and that's all the more important when you have lots of different APIs running. There are a lot of great products around to help manage that. Of course, there's the gateway models, API gateway from AWS, or APM, or the API management system from Microsoft Azure. Great solutions for that, but it is something to keep in mind. For those of you who've been programming for a long time, I kind of equate this back to the COM days. So anyone who's done C++, or MFC, or VB6 may remember the concept of DLL hell. So back from Windows NT or earlier, and when you made a change to an interface, things broke. And that's today with the interface, especially in .NET and C#, it's a little more friendly. But back in the old days, you'd always wonder why something was failing. And oftentimes someone changed the parameter of a function, which then broke the interface, which was in the registry, and blah, blah, blah. It was rough. And so that same kind of concept sort of applies here, in the sense that, really, when you're building microservices, you want to have a very sort of deliberate plan when you build out your interfaces. So I think we can all agree that, microservices have a lot of great functionality, but there's a high barrier of entry, right? You need to be able to host them properly. Today that could either in the cloud, that's probably like a container services, or if you need orchestration, the predominant player today, of course, is Kubernetes. And so there's challenges, of course, there's a lot of infrastructure there. So let's talk a little bit about, how do we break down this barrier of entry? And that kind of brings us to Dapper, right? So Dapper here is lowering the barrier of entry. And so right off the bat, Dapper, what it is actually just an acronym, right? It's a distributed application runtime. Whether you're developing locally, like we're going to demonstrate today, or you're leveraging Dapper in a Kubernetes cluster in the cloud, right? Dapper gives you a common framework to sort of tackle the challenges of building microservices, and it also keeps your code platform agnostic, right? So it's a portable, event-driven runtime. It makes it easy for a developer to build resilient, stateless, and stateful applications, that can run either locally or in the cloud or even on the edge, right? And using a diverse set of languages and frameworks, and we're going to go all into that. So let's talk a little bit about the goals of Dapper, right? So really, the mantra for Dapper is any language, any framework, anywhere, right? So the Dapper framework, it offers best practices in developing microservices by utilizing this concept of building blocks. So through this presentation, we are going to go through a majority of the popular building blocks. You can think of the building blocks as really the core services that Dapper offers. Right? So if we sort of break down this diagram a bit, you can see at the top, Dapper is designed to work with a multitude of languages, right? So, again, today's focus will be .NET, but this just as easily could have been a Java discussion. It could have been a Node discussion. You see Go there. Go is very interesting because Go is actually the language that Dapper is built in, right? So you may be thinking, I need to know Go to work with Dapper, and that is absolutely not the case, right? So the model, and I'm going to sort of shift over into some of the concepts now. Again, like we discussed, we have these building blocks that we're going to go through in a minute. But let's talk about the sidecar model, right? So the sidecar is essentially how Dapper operates. So if you think about your microservice, and I'm just going to use sort of a container. Let's say you're running your microservice in a Docker container locally, to start with. You have Dapper actually is essentially a secondary container that you talk to, right? And each microservice gets its own instance of the Dapper sidecar. And you communicate with the Dapper sidecar either using just raw, sort of REST calls, over HTTP or gRPC. But most likely, for a majority of the languages, there are SDKs. And today, in our conversation with .NET, we're going to talk a bit more about the .NET SDK specifically, and we'll show you some examples of this. So those of you who are not familiar with the term sidecar, it comes, from, if you've ever seen sort of old movies of motorcycles with sort of carrying an extra person on the side. It's attached to the parent, which case would be the motorcycle, but and the motorcycle is what actually moves it, has the engine, but it kind of holds an extra person. And this kind of pattern, I guess it's a very loose abstraction of that original use of sidecar, but that's kind of sort of where the term comes from. And so let me just show you some quick diagrams here as far as what a typical sort of Dapper's service and sidecar sort of look like. So we have so the Dapper runtime. The runtime has its components. We're going to get into components in a minute, but essentially you see on the right-hand side of this diagram, you have your different sort of physical implementations, right? So if you think of components as sort of abstractions and the building blocks as abstractions, those components talk to real physical systems, right? Whether they be your databases, your caching, your pub sub infrastructure. And as we sort of see here, we have, on the left, you can see how in the case, and what we're going to see today in the demo is sort of Docker, being our host. But, you could easily swap out Docker for Kubernetes or another cloud orchestration or, container orchestration. And, that will work in a similar manner. So here's actually sort of an example of what your Dapper application interaction might look like in Kubernetes, right? So if you're familiar with Kubernetes, and disclaimer, I'm no Kubernetes expert, so so we won't be going too much into Kubernetes today. But the general concept is that you have this idea of a pod, right? So a pod could be one or more containers. So the pod is a perfect sort of abstraction for this combination of your service container and the Dapper container. Right? So as you can see here. This is really mainly for reference. And as far as SDKs and frameworks go, like I mentioned, .NET will be today's focus, but Node, there's a lot of examples online with Node, of course, Python, C++, Rust, and again, of course, HTTP, right? So as long as you can instantiate an HTTP client, you can talk and use Dapper. So let's, and some other integrations here, right? So you'll see alongside of sort of running your own microservices, there are, especially when we talk about the concept of bindings, there is some integration with Azure Functions, Azure Logic Apps. We have APM up here again, which is sort of, the API management. The VS Code, there's an official plugin for Dapper. I'll talk a little bit about that later in the demo. We won't be using it today because we'll be using another plugin and another sort of runtime to help with Dapper. But I'll save that for a little bit further down in the presentation. Another concept is also the idea of observability and monitoring, right? So out of the box, Dapper supports the open telemetry. So there's a lot of products that sort of support that framework. So your new relics, your application insights, and we'll talk a little bit about logging today. As I mentioned in the beginning of this presentation, logging and sort of that centralized tracking of microservices and their communication can be a challenge, and Dapper makes it a lot easier. So let's jump right into the building blocks. So this is essentially really the core functionality that Dapper provides us. So let's start with what actually is a building block, right? So the building block is the API, right? So that you talked to when we looked at the sidecar slide a couple minutes ago, we saw sort of those REST commands that you could issue to a building block. And so really the building block is that set of functionality, and a building block may use one or more components. Now, a component, is again that bridge between sort of, or an abstraction, so to speak, of a service. And so let's say we have the service invocation building block. That's one example. And so you would need, in order for a service A to know talk to service B, you kind of want to be able to sort of find service B. And so that idea of service discovery, very much like a service mesh, but and that comes out of the service discovery component. Pub sub broker. So you'll see we have abstractions for pub sub, but behind the scenes, you're going to want a real implementation, whether that be Azure Service Bus or RabbitMQ, or in this case, on a local environment, we're going to use Redis today in our examples. And hopefully, if we have some time, maybe I'll show you, be able to swap out components quickly and show some of the benefits there. So on that, let's look a little bit about, let's dive into the first building block, right, which is service invocation. So really the question is, how do I discover or invoke methods on different services, right? How can I call those services securely and apply access controls? How do I handle retries when I talk to these things, right? So, all of this is sort of provided by the service invocation building block. So as you can see in this diagram here, let's say service A wants to talk to service B, needs to get information from service. So how does it do that? Without being tightly coupled, right? So I think, again, one of those concepts, again, sort of best development practices of loose coupling, and Dapper provides a lot for that. So when you have your service A, if service A wants to talk to B, what service A is going to do here in this scenario, it's going to talk to its Dapper instance. Remember, each service has its own sort of Dapper instance attached to it. That Dapper instance has obviously the technology, and the configuration to find and do the discovery for service B, right? In this case, we're establishing a TLS, connection. Once we discover which Dapper instance is paired up with service B, and what will happen is those calls will then be channeled through the Dapper containers, right? So service A talks to its Dapper, let's call it service A Dapper. Service A Dapper looks for service B Dapper, finds it, sends the request over. That Dapper instance or service B Dapper talks to service B, and then you have the return communication back, right? So all the communication is handled through the sidecar. So this is interesting, right? Because this is probably what most of you are probably thinking is this is not really the best way to do it, right? And that's true. Most microservices best practices are more of a pub sub, which we're going to get to next. But in those scenarios where you do need sort of a synchronous A to B call, there is an option here to do that. So let's jump over to, so before pub sub, let's jump into state management, right? So what else do microservices need, right? They need to be able to sort of save their current running state, being able to sort of manage data, like most applications. So Dapper provides an API for that as well, right? So again, in the concept of abstractions here, the service A does all its data management through Dapper, or does a particular set of data management through Dapper, and then Dapper's configured, the Dapper sidecar is configured to use a particular state store. In the example here, we're showing key value pair with Redis, but we could easily swap that out with SQL Server, Cosmos DB. You can see it's a very Microsoft centric, the technologies that come right to my head, but also sort of Amazon, DynamoDB, MongoDB, other relational databases, of course, Postgres, MySQL, and so on. But here we go. So let's publish subscribe. So as a lot of people know, sort of the pub sub is really sort of like a preferred way for microservices. Again, it's loosely coupled. It allows sort of more of that sort of topic publishing, right? Being able for multiple services to sort of react to one event. And again, Dapper provides a great framework to simplify that. And again, with the concept of those abstractions, right? You can develop and locally, let's say with just a Redis server, but then through a configuration, switch that out to a RabbitMQ or a cloud-based service or an event grid-based service, Apache Kafka, of course, Azure Event Hub. And just to sort of give an example of sort of what publish sub looks like, you're sort of here we're using the straight, the diagram is showing the straight HTTP calls, but we sort of send our packet through the Dapper sidecar. The sidecar is configured to talk to the pub sub infrastructure, and then of course the subscribers at the same time when the whole system sort of boots up, sort of everyone registers and with the framework that's configured. So we'll sort of move on to bindings. So bindings, just really quick, those of you who are familiar with Azure Functions again, or AWS Lambda, right? So bindings are essentially a model where you can declaratively sort of specify how a microservice essentially talks to a particular, either receives messages to execute. And again, I'm going to use Azure Functions as sort of a primary comparison. So in Azure Functions, you have this idea of a trigger, whether it's an HTTP trigger or a queue trigger or a service bus trigger. You have the triggers sort of initiate the invocation of the microservice, and then you can have additional declarative properties. Again, go back to Azure Functions. If anyone has worked with Azure Functions in .NET, you can use attributes on your method to declare, what blob should be opened, or where what blob should be saved to, along with, a trigger, that listens, that essentially listens on the HTTP port. So that's essentially bindings. We're not going to go into it too much in the demo, but just wanted to, for completeness, sort of talk a bit about that. Secrets management, another big feature here. There's a lot of secrets options out there. Again, most cloud providers like Google, AWS, of course, Azure Key Vault. Those of you, Kubernetes itself has a sort of a secrets management system. And of course, third-party tools. HashiCorp Vault is a very popular one, right? And then same mechanism again. Your application again talks to the sidecar. The sidecar, handles the saving and retrieval of secrets. And so won't be going into secrets too much in the demo today, but just again for completeness. And finally, sort of actors and observability. So the actors essentially is an actor model. Now today, I'm not going to go into the actor model. It's probably worthy of a presentation of its own. Essentially, a design pattern is great where you have maybe a lot of microservices with a small amount of state. Good examples of this would be, again, from the Azure side, durable functions. But probably better if you look at akka or like akka.net and what those frameworks provide. Those are good examples or sort of more popular examples of the actor framework in play. There's some links at the end of this slide that we'll share that goes into some more, but we will not be demoing that today. We're really pretty much talking about it anymore after this slide here. So on that note, we're getting close to the demo now. But before we get to the demo, I want to talk about another project that we're going to be using. So when I was putting this slide deck together for this presentation, I started working with Dapper. Dapper can be pretty laborious to sort of run manually, right? So through my investigation, I came across another project, an open source project called Project Tie. Now, Project Tie is actually sponsored by Microsoft. It is, it is under the Microsoft, GitHub entity. What Project Tie does is it lets you run and debug microservices. It very much has a feel. The best comparison I can give you is that it very much feels like Docker Compose. People familiar with Docker know that you can wire up and launch a bunch of Docker containers at once with one file, Docker Compose file, YAML file. So Tie works in a very similar manner. There is by itself, Tie can read your .NET solution and then run everything in the solution. But what you'll see here is we'll use a configuration file to sort of extend that functionality of Tie. Now, Tie has this concept of extensions. And of course, one of the extensions it has is a Dapper extension. So Tie will scan your services and then sort of wire up the Dapper infrastructure for you. And when we get into the demo, I'll show you the Tie configuration. But I'll tell you right now, the demo, the debugging, what I'm going to show you a lot of today is actually very Tie dependent, and it's and what Tie gives you is not only this sort of local experience that it gives you the best of Dapper, but also gives you a very simplified way to run everything at once. But it also has a great deployment story. Again, something we're not going to go into today, but with a couple of lines at the command prompt, you can easily deploy your local environment to a Kubernetes cluster, right? And so Tie, again, it's in preview, so you even turn on that little preview flag in NuGet when you want to use it. You actually use NuGet, the .NET tools from the command line to install it to actually get the Tie tool. It is great. Like I said, this presentation would be maybe half of what it was without Tie. So I just want to, give it its own slide, and it's not the main focus of the conversation, but it will, for anyone, this source code. Of course, everything that's here today will be available on GitHub. I encourage people afterwards, to grab it, and especially if you install Tie, you'll be able to sort of run it with one line, sort of one line of the command prompt. So let's get into the demo. So just one more slide here for the moment. So today we're going to have sort of this test application. It's usually the store and the basket and the order. So I thought we'd do something a little different. It's an order car service, so it's not that original, but it's a little different. And today we're going to actually there is no UI today, so we're going to use actually the Swagger integration, to show how these microservices, and in our case here, our microservices are very much just regular .NET web APIs, right? So that and so we're going to have that functionality, and sort of we're going to sort of really drill home the idea from an ease of development, how easy it is to start with this. We're just gonna go into the Swagger, submit a request, and sort of debug and sort of experience how you can actually debug multiple microservices all in one session. So at this point, I am going to let me just stop sharing this here, and let me come and share my entire screen here. Okay. All right, excellent. So let's bring up. So today, right, so I am going to use Visual Studio Code as our example, as our IDE, and that's mainly because like sort of the official TIE add-in, is a VS Code add-in. There are also like I had mentioned, there was a Dapper. There was also a Dapper, official Dapper extension for VS Code. What I've learned over my investigation is that the Dapper plugin doesn't necessarily work well with TIE, right? So because the Dapper plugin, the Dapper extension essentially likes to launch its own instance of Dapper, and it causes confusion. And so I actually have it uninstalled at the moment. So today we'll primarily work through TIE. So VS Code, there is Dapper integration. There is an unofficial plugin for Visual Studio, as well as JetBrains Writer. So full disclosure, I actually was planning originally to do leverage Writer for the full presentation as sort of like just maybe sort of push myself, try a new IDE. But at the end of the day, again, found that the best integration and debugging experience at the moment is in VS Code for TIE. So we decided just to go ahead with VS Code for today. So hopefully the font is big enough for everybody. Let me get over here on the left. Let me just sort of go through the project. So we have a typical .NET solution here on the left. We have three services here today. We have the order ride service. That's our entry point into the application. The order ride service, when it gets the order request, let's pretend, we're pretending a mobile app is sending the request. We're getting a JSON packet submitted to the order ride service. That order ride service first needs to ensure that look up the user, right? So it will use that direct invocation, that service invocation, to call the user service, which is also just a web API project. And then finally, the driver location service. So here we're sort of mimicking, finding that closest driver that you would find. You would find, obviously a real application would be a lot more complicated, but in this case, this will create a driver and assign it, right? So, so those three projects there are again, it's a .NET 5. They're just straight up web API projects. There is a front end that is still in development. Hopefully it'll be updated on GitHub shortly. In a couple of days, that'll be most likely a Blazor server, and that has to do with the integration, some of the Dapper integration, maybe not being quite ready for Blazor RASM, but I have some more playing to do with that. Actually, while I'm talking, I just want to delete that logs folder because I'm just going to clear out some old logs. But otherwise, yeah, we have a solution file here, traditional .NET, for the most part, solution. So the two things that you have here, which are different. So we have a components folder. So remember we discussed components earlier. Components, if you remember, are really they're the abstractions of the physical services that the building blocks use. And so what we've defined here, so when you install Dapper out of the box, you get sort of the developer Redis integration. But what I've come here is I've defined my own components, right? And then these will be used. So I am still using actually Redis as our pub sub mechanism today. But you'll see in the state store, my state store is also using Redis. So it looks like we had a little change in our code recently. So that's fine. We'll just, but understand that I can show you an example of at the end of this presentation of maybe using a different store, right? So again, Cosmos DB, SQL Server, but these YAML files are that bridge, right? So that those configuration files are really what tell Dapper, which infrastructure to use. So before we get into the code, let's just talk about the tie YAML. So the tie YAML, again, is kind of like that Docker Compose file where you can come in, you can specify which services you want to run, and any other sort of extensions you may want to have. And I actually realized what the problem is. I meant to show my components here, sorry. And as you can see here really quick, just that, I haven't commented out, but with uncommenting these lines and commenting above, we can switch over, ideally, from Redis to Cosmos. And then you just sort of restart the application. And now our state is using Cosmos DB. And again, hopefully with time permitting, we'll have time to show that. Otherwise, back to the tie YAML. So we'll start. I'm going to go a little out of order in the file here. So in the actual YAML file, this is where you would define which services you want to run. Again, if this were just, and again, Project Tie isn't directly tied to Dapper, so Dapper is an extension here. So if you just wanted to run a front end, back end application together and debug it together without any of the Dapper integration, you can do that with Tie. Again, if it's that simple, you might not even need to have this particular configuration file. But if you want to configure your services to have some level of discovery, a front end being able to discover the back end, then you start to need the tie YAML. And in our case, we're actually going to offload all that functionality to Dapper. So we definitely need this file. So after declaring the services here, we're going to move back up to sort of the extension section. Now, the extension section, I'm defining two extensions today, right? So first one, again, we'll jump around, Dapper. So for the most important things here is in the Dapper configuration is the component path. This is where I could specify my components. And that's where, so they would accept my overrides. In the command line equivalent, if you're running Dapper from the command line, again, this is something you would just feed into the command line, the commands path. I have some other configuration here. So let me just show Docker really quick. So a default installation of Dapper sort of installs 3 containers, right? It instantiates 3 containers. You have a Redis out of the box, placement, which is sort of like the engine that sort of runs and sort of helps with the creation of the Dapper sidecars and sort of helps with that communication. And Zipkin is has to do with the observability and sort of the logging. So, and as you see, when we run this, you'll see a lot more containers pop up. So just to show what the initial state looks like, that is that. And then there's additional configuration, but that's what we'll go into that for now. So let's talk quickly about the code, right? So I had mentioned during the presentation that we will be one of the benefits of using Dapper with .NET. Specifically, there is an SDK, right? So again, the NuGet package here. If I just open up the solution here, you'll see there's an ASP.NET Core app NuGet package. What that does is a couple of things. Essentially, it helps allows some of the dependency injection that we're used to. It sort of configures that. Let me see if I have let me look at a startup, right? So in the startup here, as you can see, otherwise very much a traditional .NET Web API project. The only things, let me just remember what's different here. As you can see, we got our Swagger configuration here. What we do here is essentially we just wire up some endpoints, right? So this use endpoints is that's part of the routing. We have the cloud, we essentially tell it to use cloud events. And one thing we have to do initially turn off is HTTPS redirection. One of the things with Dapper right now, if you think about a Kubernetes cluster, usually you define, or sort of a production level cluster, usually you have like an ingress point, right? And that point would be whether it's Nginx or, you're using API management, and that's kind of like where your HTTPS sort of resolution may occur. So very likely that your containers and your communication is using standard HTTP within them, within the microservices or microservice to microservice. So what I've found, especially again, a lot of this stuff is still, relatively new. Turning off HTTPS redirection is helpful. And that's why you'll see that turned off in all the projects. And then, so here we go. And so when you add controllers, we're adding this Dapper extension, again, a very traditional ASP.NET sort of configuration model here, an extension method that essentially will, implement and register the appropriate services. If we go into now the ride controller here. So this controller is our main entry point again, right? So as you can see, we have references to Dapper and Dapper Client. And so it gives us a couple things, right? So the Dapper Client is like our HTTP client, right? So this is sort of how we're going to leverage the Dapper building blocks. Again, instead of using an HTTP client and making those calls ourselves, the API gives us this object to use instead, right? The Dapper Client. And so the Dapper Client, what Dapper also gives us is this integration to leverage a declarative model for in our case, pub sub. So this particular API is, we're going to access it through REST. But at the same point, by declaring it with this topic attribute, we're saying, listen on this message bus and listen for this write ordered event. This method would also be called, through a service bus or, a pub sub model of an event being published to it. So right off the bat now, with just that one declarative line, our API is now supports, our endpoint is now both, supports REST and, is now registered, to listen to events. So that's sort of one use of Dapper in here. Another option is, what we'll do is when we debug, we'll go through this and we'll do the invocation. And we're just going to scroll down here to the actual method. You can see here we're using the Dapper client that was injected in the controller to actually call a service, in this case, user service. And we're doing a get call. So we're actually, kind of feeding the parameter in through the URL of the user ID, which is in our case here will be a GUID. But you see here, that's all we have. There's no configuration in this application about where user service is. There's no, the Dapper framework provides all that. Yes, there's some coupling, of course, right? So you have to know that there's a user service, right? Yeah. So and I'm sure, and there might be more creative ways to inject those elements as well. But a lot less work than maybe some other ways of sort of configuring a front end and back end. So I think I've sort of talked enough. Let me just start running. So I'm in the directory here on my console on the right. So I am just going to run Thai now. So it'll find that configuration file in the root here. and it will kick off the application. As you can see here, it is launching the container. So it'll take a minute to do the container. So while we do that, let me actually go back to the Thai YAML one more time and talk about one other extension. So again, during the presentation, I talked a bit about sort of this idea of open telemetry and sort of being able to track events across microservices, and that being one of those main pain points from very early in the presentation. We discussed, one of the real pains in microservice development. So another extension that Thai supports is SEC. If you're not familiar with SEC, it's brought from it's a UI. It's a log aggregator UI developed by the team that develops Serolog, which is a great logging API. Now, those of you who developed a lot in the .NET framework, remember that we didn't quite have the level of log integration that we do now in .NET Core, and so there were a lot of third-party, of course, Log4net. It was around for years, nlog, but in that time, Serolog became a very popular, a very robust logging engine, and I still support it in many applications today. And SEC will give it came out of sort of that Serolog team. Now SEC, and we'll see here, will give us a real great insight to all the services in one place. So that's the benefit here. So it looks like we have finished running, and we're so let me just bring up Docker really quick. As you can see now, we have a ton of containers running. So, we have our SEC container running, and we have our services running. So you'll see we have our service, and then each service has a proxy, and then also a Dapper instance and a Dapper proxy. And we can, through Dapper, a Docker desktop, you can see a lot of this. But more interestingly, let me go back to the browser for a second here and stop that repeating. We're going to bring up what Thai does when it runs, it also provides a dashboard. So you can see here, we can see everything that Thai is running in one place, and we can also get to the endpoints. So as you can see here, we have SEC. We're interested in SEC. We'll come back to this in a minute, but you can see here, this is sort of logging, aggregating the logs from the different systems. And we have our services. So again, to show that, these are really just straight up .NET Web APIs, I'm actually going to launch one here, and let's bring back my bar here. And because we are, if you've ever done Web API development, you know that by default, the root doesn't resolve anything. We just need to go directly to the Swagger. So here we are, right? So here's our order ride service. It's a open API 3 specs, Swagger files being created. And we get this ability to test our API right through the web UI. So what I'm going to do here is, before we execute this, let me go back to Visual Studio Code for a minute. So I mentioned in VS Code that we have this Thai plugin, right? So now that Thai is running in the console, you can see that the Thai plugin sees the different services defined, and under other services, you'll see all the Dapper instances and as well as SEC. But what we're going to do here is at the root of this, we're actually going to attach debuggers to all these services in one click here. So as you can see now in VS Code, we're now attached to a bunch of the services. What we care about right now is the order ride service. It looks like we still have some of the old ones from a previous run. No, so that's the wrong one. Sorry. So this is the current one. And throughout the code here, I have some breakpoints, right? So we're going to go back to our Swagger. We're going to come here. Actually, I'm going to go back to Visual Studio one more time. Let me just go to samples. Let me just paste this up. So again, in our ride application, we're sending a user ID, and we're sending a start address and an end address. This happens to be in New York City. And then my user ID as a GUID here. I'm going to paste that into here, and I'm going to execute this. And it's hard to see on the bottom of the screen, but you can see that VS Code is now flashing. And now we're in debug mode, right? So again, up here, you can see we have the three different services that we can switch between. And what we're going to do first is we're going to sort of go through that direct service invocation. We are, so just like any regular sort of debugging tool, I'm going to step into this method call. That's going to bring us into what I showed you earlier. If I just go through each of these lines, this call here will now, I'm actually just going to play it. Now you're going to see, all right, so it chose not to attach, but ideally this would have stopped. This would have stopped here. I will say, still work in progress. Again, it is pre-production, so I've noticed a couple of demos here that sometimes it works, sometimes it doesn't. But ideally, we would have stopped here. We would have been able to continue debugging through the second service, and then we would come back to the first service and sort of continue, right? And so we'll run this. If we go through the log files down here, you'll see, sort of sprinkled through here, you will have seen some log entries as far as, user created, if it didn't exist, or user found. Actually, we're still executing here. Sorry, let me. Oh yeah. Oh, so it finally did make it there. Sorry. So it did work. So let me just play this really quick and finish that execution. I see we're running out of time, so let me just finish this quickly. So as you can see, throughout a lot of this debug information, we do have some demonstration that things work, right? But to sit here and go through this is really, it's not very useful, right? So I just want to wrap it up really quick with sec. All right, so sec, again, let me just refresh this. So sec is this aggregator. But what you'll see as you expand it, it's very much based around this idea of structured logging. If you're not familiar with the concept of structured logging, it's more than just sort of a simple text logging, right? You're logging an object, right? And in this case, we're getting a lot of telemetry per log item. And one of the great things here is, and what sec allows you to do is actually filter and query on these. I think it's using like Elasticsearch behind the scenes here. But let's say I wanted to see everything for order service. I could just come up here and filter, just give me where everything is application order service. And now I can sub-filter out. But what's even more interesting is, let me just clear this out here and refresh, is the idea of like this ride ID, right? So let's say I want to filter on this GUI. I'm just going to do a text search for now. Let me do something a little different. Let me do ride here, right? So what we could do is say we wanted to see, we only have one ride. That's why I deleted the logs before we ran. So they would just have this last demonstration's worth of content. But you can see here, we can sort of look at, a whole sequence. And as you can see here, we have the order service, but then we can see that the ride was sent. Again, this is order service. Let me just delete this out for a second here. Right, user service. Okay, so ideally you could come in, you could service, and as you can see here, we have multiple, all the services are in one place, right? So when you're dealing with a much more complex application, a real application with multiple services, right? Just with those 2 lines of code back in that YAML file, right? You now have this aggregated logging in your solution. So I see we're running up on time, so let me just go back to the slide deck and just finish up really quick here. And we'll get on our way here. So let me just share this stuff here. All right, so just Quick caveats, right? So a couple of things, as you saw, right? So first off, Project High is great, but it is preview. As we saw today, not 100% consistent. A good excuse for me, I guess, in case things go wrong. Also, as far as Dapper goes, what I've noticed online, you see a lot of stressing on the, or that service to service invocation. I showed that today, and the fact that the other services talk to each other, and we didn't go into it too much, is and actually, let me just quickly show. Let's go back to sharing the whole screen here for a second. Let me just stop and then share the entire thing again. Right. So today we were using Redis for everything, right? So as you can see, these particular keys here, these are the state stores, right? So everything that was being saved saved to this one store. Now, another caveat is, again, out of the box, this one store configuration, again, is also counterproductive or counteractive to sort of best practices for microservices. I do know that Dapper now supports this idea of namespaces, which essentially would break this up into a more accurate representation where, you could really implement that one data store per microservice model. So again, sort of, hopefully this inspired you to sort of look into it more. And when you do, you'll see that there actually is a lot more advanced configuration to sort of really make this more robust. But here, just to show the events and show that eventing was happening today, you can see here again in these Redis sort of stacks were put together, and the events that we were publishing between the services were actually being created here. And you can see a ride created event was created, a driver assigned event. So when the driver was, so the driver service responded to the ride created, it found a driver and then published back that driver information, which then the order ride service also listened to again, and then again with those controllers, the attributes, and then was able to respond accordingly. So just back to the slides really quick. So this project will be, you can use this bit.ly link. It'll take you to GitHub. It'll bring you to the code. I have a little bit more work. Ideally, I'll put a front end in front of it as well. It'll be part of that Dapper cluster. But again, a Blazor server app that will also listen to the events, right? So you would be able to publish the message, to the bus from the UI and then display the response. And that's the last piece, really to make the demo project kind of complete, and really, fully showcase that. Some additional links. Dapper is there's a lot of great documentation, I'll say. It's very extensive. A lot of the diagrams today are from the official Dapper documentation. There's a lot of great videos out there. Especially Microsoft has a lot of great videos about Dapper. It's not an official Microsoft project, but there is a lot of support from Microsoft. If you're more interested also in the sidecar pattern, as well as Project High, there'll be links in the presentation that we share with that as well. If there are any questions, I know I ran really up close to time. Of course, my contact information is here.
Yes, we do have questions. We do have questions. Yes,
all right.
So first of all, congrats for the presentation. Really insightful. Let's have one question, then we will introduce the next speaker, and then, well, let's see. Maybe we have other questions. Why not? So the first question is about auto-scaling of microservices involved in a solution in terms of the features of.
So yes, it does. It does with Keda. It has Keda integration. And again, I'm not the expert on that end of sort of that Kubernetes setup, but I do know there are integrations that support that. And I believe Keda with Apache Kafka is sort of, and maybe sort of how it's scaling the eventing portion of it. As far as actually how Kubernetes sort of scales, I would have to say probably refer to the documentation for a better answer than I can give you.
Okay, then we've got another feedback. Great presentation, Vincent. I feel the same.